think I have a microphone on the camera that is on top of my thing. I don't use the camera, but apparently it has a microphone on it. So, how's geometry going?
Not terribly bad. It's just like I have some of the answers down. I'm not like because like we did some of this stuff as well. Like in class, he gives this packet. I'm just like not sure on some of this stuff.
Okay. The files you attached, some of them like this one, I can't
Yeah,
see the instructions. Can you see what I'm looking at here?
I can.
I assume they want to know the measurements of the three angles of the
Yeah,
triangle.
yeah. It says find the unknown angle measures in each triangle. So that's yeah.
So let's do it this way. Hold on 1 minute. Okay. So tell me what this angle right there is.
That one. Hold on. I'm trying to see if I can full screen this real quick.
Mm,
That's better. Okay. That isn't that
yeah,
angle 60?
you can also minimize the GoToMeeting control panel by clicking on those two arrows, and that'll shrink that up and make more space on your monitor to see. That's a toggle switch, those two.
Okay. Perfect. I got it full
Yeah,
screen.
okay, good. And then you click them again and it'll expand it if you need to see the entire control panel.
Okay, so wouldn't that angle be 60?
What's the sum of those two angles have to be?
180.
Okay, so what is it?
Wouldn't it be 35 then?
Okay, a really good skill to have in geometry is being able to subtract from 180. Because 180 is the magic number in geometry.
Oh, 55. I
Okay,
was stupid.
so that's 55. That's an isosceles triangle, right?
Yes.
What's the other angle opposite it?
Wouldn't it also be 55?
Yeah, in other words, if that side is equal to that side, then that angle is equal to this angle, always. All isosceles triangles are like that. So now what is K?
Isn't it the same?
No, if it was an equilateral triangle, it would be the same. But all three angles have to add up to what?
180. So it'd be, if that's 110, it'd be 70.
Okay. That's how you do most geometry problems, which is
Okay.
you solve for something you can solve for. The first thing we can solve for is that. And then you use the other information to solve for one other, and then you use both pieces to solve for the third.
Okay.
So let me go down to the second problem. This one, I don't have a picture of the thing. So we can do one of two things. You can take another picture of it and send it. This time, send it to my email.
Okay. I think I'll be able to do the 5, 6, 7. I'll think I can do that one,
Okay.
but I really do need the help on like the 8, 9, 10,
Okay, let's go ahead and do 8, 9, 10.
and 11. Yeah.
Let me just add one thing. When you're going to send me pictures, send them to my email address.
Okay.
Because that's what I'm looking at here is my email address. When you send it to my phone, I have to forward it to my email address. And I don't know if they always forward exactly the same.
Okay.
They probably do. But my email address is where we are working on, not my phone.
Okay.
Okay, so let's look at this thing they've drawn over here. Let's start labeling. Once again, same problem. is we label what we can figure out, and then we can figure out the rest. So if we look at the triangle that is PQT,
Yep.
what kind of triangle is that?
Isn't that what is?
First of all, it's a right triangle, right?
Yeah, it's a right triangle because it's got a 90 degree angle.
It's also a what? It's got two sides that are the same.
Aren't they congruent?
It's an isosceles triangle.
Isosceles, yeah.
Yeah. So since it's an isosceles right triangle, angle Q, this angle right there, has to be the same as that angle right there.
So
what is the measurement of each of those?
So P is 90.
So P is 90, and the sum of all three angles has to be 180.
180. So that leaves you with 90. So it'd be 45.
Right. So that's what that is right there. It's 45. PTQ. Okay.
Then QTR.
QTR is this tiny little angle right there. First of all, let's look at, here, let me erase everything. Let's look at this triangle right here. What kind of triangle is that?
Is that just isosceles?
Well, at first glance, it's just isosceles, what does that make those two angles if it's isosceles?
Equal.
Okay, they're equal. What would they total?
180 as well.
All three total 180. So what are those?
Yes. So wouldn't it be 60 and 60?
Yeah. In other words, those two total 120, which makes 60, 60, and 60. This is an equilateral triangle, or it's an equilateral and equiangular triangle. So we know that part of that angle is 45, right?
Yeah.
In other words, if we know that that is 60 and we know that is 45.
When you just subtract the two?
Yep, to get that.
So you get 45 and 60, that would leave you with 15.
And that's what that looks like. Always make sure that it looks right. In other words, if we came up with an answer of 80, that does not look like an 80-degree angle, right?
Yeah, correct.
15 makes a lot of sense. So always give it the ballpark check.
And then you got P.
All right, PTS. That's this one right here.
P. So wouldn't the T area, wouldn't that be one? Wait, never mind.
Let's look at the triangle TRS.
Okay.
What kind of triangle is that?
Isn't that also it's also an isosceles when you first look at it, correct?
Well, we got three equal sides.
So
that's not isosceles, that's equilateral.
Equilateral.
And all equilateral triangles have what measurements for their angles?
Isn't it 60, 180?
So that one's 60 right there. We figured out that one's 15 right there, and that one's 45. So the whole thing is what?
Wouldn't that be 120?
Yeah, so that's 120 for that.
And what kind of triangle was that again? I forget. That was a equilateral.
Yeah, here, let me just do a little drawing for you here. That's isosceles, okay? You see where I'm drawing?
Yeah.
Because it's isosceles, those two angles are equal. If I
Okay.
have three equal sides, that's equilateral. That's equal to that's equal to that. That makes all three angles equal to one another, which forces them to be 60 degrees.
Okay.
Just an isosceles, then I can have all kinds of combinations. These two side angles could each be 10. But once you get to be equilateral, all three sides are the same, all three angles are 60 by definition.
Okay.
Question 11.
So then, like the little bottom part that's cut out, it's just angle L. And it says, what is the measurement of angle JKL? Wouldn't it be 180?
JKL is this angle right there. What kind of triangle is that?
Isn't that also, that's an isosceles?
No.
Equilateral?
How many equal sides does it have?
3. So
That's
it's
always equilateral.
equilateral. Okay.
2 is isosceles, but 3 is equilateral. And isosceles, you don't really know all the angles. Equilateral, you always instantly know all three angles. What are each one of them?
60.
That's what angle JKL is 60.
So if I explain that, so it'd be, what is the measurement? It'd be 60 degrees. Then wouldn't it just be
Equilateral triangle.
because it's equilateral? Okay.
That's all you need to say.
Okay, perfect.
Here, let me scroll down here and see what else I can actually see here.
I don't need help with 12. I just need help with the
Okay,
11.
good, because I don't have a picture of the ladder. Number 4, I don't see any picture at all.
Number 4, hold on, where's that?
Do you see it on my screen?
Yeah, yeah, okay. What was it? Number 6 was like one of my main ones.
Okay, let's go look at 6. All right. This is a little bit of a strange question, first of all. First of all, tell me if those two triangles are congruent.
They are.
Yeah, they are. But whether we can prove it by side, I'm not sure. I guess we can. First of all, the diagonal is equal to itself. So that's one side. The two short sides, they have a hash mark on them, so they're equal. Hold on one second. In other words, this one is equal to that one. Now, the question is that side number 1 equal to that side number 2, which we would need to be true in order to prove congruency based on side.
Yeah.
But how do we know that PQ is equal to SR?
Peak. Because aren't they congruent?
They are
They
congruent.
both have 9-degree
Here's the way I would
angles.
prove they're congruent. Because the two short ones are parallel to one another,
Yeah.
that makes that diagonal a transversal, and it makes that angle equal to that angle. It also makes this angle equal to this angle.
So isn't it, so
So
it
it's
does
definitely
prove that.
congruent on angle side angle.
So it's angle side angle, not
Well,
side side.
here's the thing. I'm not quite sure what the question is looking for here. First of all, if I can prove that they're congruent, then that also says that all three sides are equal. So I can prove that it's congruent based on angle side angle. And then I can say because it's congruent, all three sides are equal. The question is do they really want us to prove that it's congruent based on side, side, side? It looks to me like they do. Is there sufficient information to prove that SPQ is congruent to QRS? Well, there definitely is enough information to prove they're congruent, but can we prove they're congruent based on side, side, side? In order to prove that, we have to prove that PQ is congruent to SR. Now, there's various formulas in geometry. This is a rectangle. Okay. How do I know it's a rectangle? Because it's got 4 right angles. And if it's a rectangle, opposite sides are equal. Therefore, that's equal to that. Now we could prove those two triangles are congruent based on side, side, side. But I'm not sure that they want all of that. I honestly don't quite know why they want you to prove that they're congruent based on side, side, side. That's not the easiest way to prove it. The easiest way is angle, side, angle, based on the fact that we have a parallel line there and a parallel line there. We don't have anything that says that's parallel with that, although there's certainly, because we have two right angles, because we have a right angle there and a right angle there, that is definitely parallel with that. And then we have
Okay.
two lines, or all sides are parallel with their opposite sides. And based on whether it's a rectangle, which this is, or a parallelogram, PQ would be equal to SR. So there's all kinds of ways I can prove that PQ is equal to SR, but I can't do it directly. In other words, there's nothing in that picture that tells me that PQ is the same as SR. They didn't put any double hash marks on it.
Okay. So I'll keep that information down.
Yeah. In other words, we definitely know that that side is equal to itself, right?
Yeah.
So that's one side. That's two sides. But we need to know that that is equal to that. And they don't state that. And it is because of the right angles. But I mean, I don't know how you want to explain it. There is sufficient information. Whether
Okay.
there is sufficient information to do it based on side, 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 that may be another matter. I think there probably is, because you can make the argument that this has to be a rectangle, and rectangles, the definition of a rectangle is PQ is equal to SR. So once you have that, now you have all three sides are the same.
Okay.
Okay? Like I said, it's curious that they want you to prove it based on side, side, side. I don't quite get that. Okay, so let's look at number 7. If we fold that flag along that line right there, we are left with this triangle, correct?
Correct.
What are the dimensions on that triangle? 13 on the hypotenuse.
And then 42.
Well, no, that's, what's this dimension right here?
Wouldn't it be 12?
Well, it sure looks like it. I'm not sure that it has to be, but I don't think it actually is, but we'll call it 12. And if that's 12, what's the other side equal to?
12.
No, that's a right.
Oh, right angle, yeah.
It's a 5, 12, 13. There's certain triangles you want to be able to spot instantly. One of them is a 3, 4, 5. You familiar with those?
Yes, kind of.
It's called, well, it's, here, I'll draw one up here. It's a right triangle, and it has the, it's called the lowest perfect Pythagorean triangle. In other words, there is no triangle that is a 2, 3, 4.
Okay.
3, 4, 5 is the lowest one. The next lowest one is 5, 12, 13. So these two are worth recognizing because it can save you a lot of effort. Otherwise, you have to apply the Pythagorean theorem in all cases. Now,
Okay.
if this is the dimensions, and incidentally, if the hypotenuse is 13 and one side is 12, the other has to be 5.
Okay.
That would easily fit in there, would it not?
It would.
I'm a little confused because it looks to me like the unfolded triangle. Oh, this one's already been folded is the thing. All right, here, let's take a look at this already. First of all, this triangle over here, is that congruent? Are they congruent to each other?
Yes, the outside one, yeah.
Sure looks like it. Is all you got to do is take this triangle on the left and rotate it, and it's the same triangle. It's 24 inches there. That's that 24 inches. It's 13 inches there, and it's the same angle. So based on side, angle, side, these two triangles, in other words, we have side 1, that angle, and side 2, right?
So I would explain it by its side angle side.
Yes.
Okay.
Congruent because it's side, angle, side. I
It's
misread
congruent.
this. In other words,
So,
that is the folded flag.
okay, so it's congruent by side angle side.
Fold it further, and that didn't make any sense to me now that I think about it. In other words, this is already folded. And the question is will that fit into this other picture? And the answer is yes, because they are congruent.
Okay, so I put like it's congruent. It's congruent. For my explanation, I put it's congruent by side angle side.
Yeah, here's side, angle, side. And we have the same over here. There's the same side, 13, the same angle in between those two sides, and there's the second side, 24. We don't know this measurement down here. They don't give it to us in the first picture, and they don't give it to us in the second picture. We don't care what it is, because we have enough information to prove these two triangles are congruent. So it has to fit.
Okay.
Okay. All right, let's see what else we got here. Okay.
Those I have the answers for, but a few of those I'm just kind of confused how we got those answers.
Okay. Tell me which
So
one.
like
Well,
number two, I'm confused how that's side, side, side.
number 2.
Yes.
Okay. Well, you know what these hash marks mean?
I don't know what the three of them are.
Okay, here's what hash marks mean. If you use one hash mark, hold on a second. That hash mark right there means that side is the same as that side.
Okay.
AB is the same as DE.
Okay.
Here they use 2 hash marks because they've already used 1. And these 2 sides are not the same. AC is not the same as AB. But here's the other double hash mark. So AC is the same as CD.
Okay.
And the third side uses 3 hash marks because BC is not the same as AB or AC. But it is the same as CE. That's hence they both have 3 hash marks.
Okay.
So you're looking at side, side, side. That side is equal to this side. This side is equal to this side. And this side is equal to this side.
Okay.
2 triangles congruent based on side, side, side.
And then for number three, it just I don't know how like I don't know how you wouldn't get I don't know how you get none. Like not.
Okay, number 3 is a bit strange. Here's the one side, right?
Yes.
There's the other side. And we have that angle equal to that angle. So what is that? That's side, side angle, right?
Yeah.
That's not enough to prove congruency. Side,
Okay.
side angle does not prove congruency. Let me show you an example. There's a triangle. That side is 10. That side is 8. That angle is 30 degrees. Okay? Now, over here, I'm going to draw another triangle. That angle is 30 degrees. That side is 10. That side is 8. Those 2 triangles are not congruent.
Okay.
So side, side angle does not prove congruency.
Okay, makes
It has to
sense.
be side angle side or angle side angle.
Okay.
Now, those 2 certainly look congruent, and no doubt they are, but not based on that or that. In fact, that's your only 2 choices. Doesn't even look like they let you use angle side angle,
Okay.
which does prove congruency, but it's not one of the 2. It looks like label each pair of triangles congruent by either side angle side or side side side, or none.
Okay.
Okay.
Sounds good.
So number 4, we got that side equal to that side. We got that side equal to that side. If we can prove that this angle is equal to that angle, we got side angle side.
Okay. Makes more sense.
Are they equal?
Yes.
Based on?
Side angle side.
No. Why are those 2 angles equal?
Because aren't the
What are these called? Vertical angles.
yeah, vertical.
Vertical angles are always equal. In other words,
Okay.
1 is equal to 2 and 3 is equal to 4. Anytime you have 2 lines cross, all vertical angles are equal. That's equal to that. That's equal to that.
Okay.
So
Sounds
therefore, now we have side, angle, side.
okay. Makes more sense.
Okay. Yeah, you have to kind of go either clockwise or counterclockwise. It doesn't matter. But notice in 3, what we have is side, side, angle. If they would have told us that this angle here is equal to this angle, then we would have had side, angle, side, and they would be congruent. But that's not the information they gave us.
Okay.
Okay. All right, let's scroll down. Let's see, are we doing, we're just doing this last one, or it's 9 o'clock? Are we only doing a half hour tonight or an hour?
I think we are. I think we got the main questions I needed, which is good.
Okay.
Okay. Perfect.
And you're okay with this proof at the end?
The proof. Yeah, I did the proof. They're making a lot more sense to me,
Okay. This
which
proof's
is
going to
good.
be it's pretty much the same as problem 4. And let's see, I don't know if you can see where I'm pointing. This angle here, you see where I'm
Okay.
pointing?
Okay.
EXW,
Yeah.
that's equal to YXZ,
Okay.
right? Because they're vertical angles.
Yeah.
So then we have side, angle, side. So that's how we're going to prove that these two triangles are congruent. Is first we're going to prove that those two angles are equal to one another. The reason being they're vertical angles.
Correct.
Once you have that, the given is that that line is equal to that line and this line is equal to that line. So you immediately have side, angle, side.
Okay. Makes more sense.
All right, Ben.
Okay. Perfect.
Let
Thank you so much.
And you're welcome. And yeah, glad you were able to schedule a session tonight. If an hour isn't enough time for you, like if you don't realize you need help until 8:30 or something, always feel free to call me.
Okay. Perfect. Will do.
The
Appreciate it.
website needs you need to give it an hour's notice.
Okay.
You don't need to give me an hour's notice if you call me. If I don't have any other thing going, I'm happy to help.
Perfect. Thank you so much.
You're welcome. Have a good one.
Okay.
Talk to you next time.
Sounds good. Thank you. Bye.